This is lesson 1.9. I'm just going to show you the master. I'm not going to write everything out because a lot of this stuff is things you've seen before. Here's the assignment, page 239, 4 through 48, every other even, 62 and 68. Now, for number 44 and 48, you need to make your own graph grid by hand on your own paper. I don't really think it's important that I provide you with paper. I think it's actually easier, honestly, to just kind of sketch it freehand. Do not convert fraction or radical values to decimals. If you start with a fraction, stay with a fraction. If you start with a radical, stay with a radical. Do not convert stuff to decimals unless you start with a decimal. All right, now the distance formula is basically the Pythagorean theorem used in a slightly different way. Now, if you want to find the distance between 2 points, you can draw a line between those 2 points, and you can see that you can figure out the vertical distance and the horizontal distance between those 2 points as well. And in drawing that, you're drawing yourself a triangle. Now, when you draw the triangle, basically, you'll have a vertical distance, which you can find by taking the top y value 5 and subtracting the bottom y value 1. 5 minus 1 is 4. Or you can find the horizontal distance by taking the rightmost x value, which is 1, and subtracting the leftmost x value, which is negative 2. 1 minus negative 2 is 3. And then, if you square both of those, and then add them together, and then take the square root, you're basically using the Pythagorean theorem up until the point where you take the square root, but that's where you take the square root of both sides in order to change c squared to c. So, you basically take 4 squared plus 3 squared. That's the leg squared plus the leg squared in order to get this squared. But then once you get that value, 25, you want to take the square root of it to find what the actual length is, which is 5. So that's where the distance formula came from, is the Pythagorean theorem. Here's the distance formula as you're probably a little bit more familiar with it. X sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And then in order to get d squared on this side, we'd have to take the square root of both sides in order to find just d. This is your hypotenuse on your triangle, your red triangle. So here's an example of how to find the distance between 2 points. If you're given 2 points, this is x sub 1, y sub 1, this is x sub 2, y sub 2. Here's the formula. Substituting those values into the formula and solving gives you an answer. The distance between those 2 points. Midpoint formula, well, that's pretty easy. It's just halfway between the 2 points. So when you add the two points together, x sub 1 plus y sub 1, and divide it by 2, you get the x value that's exactly halfway between them. So for example, if your x sub 1 and x sub 2 are 1 and 7, what's the point halfway between 1 and 7? 4. How do you find that? 1 plus 7 divided by 2. That's 8 divided by 2, which is 4. Or the midpoint vertically could be found by adding 2 and negative 3 together and then dividing that by 2. So 2 plus negative 3 is negative 1. Divide that by 2. Still negative 1/2. There's the formula for midpoint. All right. Standard form of a circle. This is the standard form of a circle. We've looked at this a couple times already this year. Notice that these are written as a subtraction. So if there's already subtraction there, that means h is positive and k is positive. So hk is the center. So for example, if the center was at 0, 0, that'd be x minus 0 squared plus y minus 0 squared. Well, obviously, you don't need the minus 0 part. You can just say x squared and y squared. R is the radius that equals r squared. So if the radius is 4, that would be 4 squared or 16. And there's the standard form of the circle, centered at the origin with a radius of 4. Notice that both x and y are squared. That's how I know it's a circle. Over here, same process. H and k are your x and y values of your center. Remember that there's already a subtraction here, so this would be x minus 5 and y minus negative 6. Obviously, y minus negative 6 would be y plus 6. And then the radius is 10, so that would be r squared, 100. The standard form of a circle is what I just showed you. Here's another example. If they have a center at negative 2, 5, that would be x minus negative 2 is x plus 2, y minus 5, both of those quantities squared. Radius at 7 would give you 49. Now, if you have a circle whose equation is this, think backwards. This would be x minus 2, so the x value of the center is 2. X minus negative 6 would give you y plus, or sorry, y minus negative 6 would give you y plus 6. So that would be a negative 6 for the y value. This is r squared, so the radius would be 2. Okay, so again, just thinking backwards, this would be x minus a negative 3, so the x value of your center is negative 3. This will be y minus 1, so the y value of your center is 1. This is r squared, so the radius is 2. Graphing this, the center would be at negative 3, 1. The radius is 2 would put us up, left, down, and right 2 from the center, and then I just drew a circle all the way around. What's the domain of this circle? Well, the x values on the left side are at negative 5, and it goes all the way over to the right side of negative 1. So left to right, we have negative 5 to negative 1. We include those two with brackets. What's the range? Remember, the range goes from the bottom to the top. The bottom y value is negative 1. The top y value is 3, so negative 1 to 3.